that happened to me before, where I closed out one meeting and I tried to start another one and it got all froze on me, so I had to reboot my computer.
No, that's too bad.
And it takes forever to reboot a computer these days. There's so many things that start up on the startup, so I apologize.
Yeah.
We can go a few minutes longer if you need to. What do we got going today?
Okay, so let me open up the site really quick.
Okay.
It's gonna take a while.
Now let's see. This is the one I can get onto. I have this saved, don't I?
Okay.
If I remember right. Big ideas in learning?
Yep. Yep. Oh wow, that's slow connection.
Oh, wow, that's
I heard it like
slow connection. I heard it like
3 seconds
No,
after.
it really is slow.
3 seconds after.
I know it. It's my computer's running. Oh, I don't have anything running either besides this. This is, I don't know what's going on. But anyway, we'll have to make do with it. Students?
Yep, students.
I haven't had to sign in before. How did we do it before? Oh, I got to
You
go.
don't need to sign in.
Okay. So, just go to Common Core. Accelerated Math. And which chapter?
Chapter 2.
Chapter 2.
And then either section 2.4 or 2.5.
Okay, let's start with 2.4.
And then anything
in here.
You need what?
Well, besides anything in there besides the first 2 pages.
So let's go
Where
to
it says,
exercises.
Yeah.
Yeah.
Here we go. Let's start with 5. Okay, let me squeeze this down so that I can fit my thing up here. Let me squeeze this down. Okay. So we're supposed to solve these equations. You're getting into algebra. Good.
What was that?
Said these are algebraic equations. That's what this is algebra.
Yeah.
So how do you solve a minus 6 equals 13?
The way I always did it was you did it backwards, I guess. So you would do 13 plus 6 to get a.
Okay, there's one fundamental rule for solving equations that works on everything. And that is that you can do whatever you want to one side of the equation as long as you do it to the other. So if I want to isolate A, what do I need to do to the left side of the equation? I need to add 6.
Yeah.
And since I'm adding 6 to the left side of the equation, I have to add 6 to the right side of the equation. Now the left side becomes just A, because A minus 6 plus 6 is just A. And the right side becomes 19. So that's essentially the way we're going to solve all of these, is we're going to isolate the variable.
Okay.
Whoops. Let me open it up that way, since we're going left to right. Okay. So in this one, we have minus 3 equals z minus 8.
So then that would mean you add 3. You add 8 to negative 3,
Okay.
and take it away, and take 8 away from z.
Well, actually, you add 8 to the right side of the equation. Try to get thinking in terms of you've got a left side of the equation and a right side of the equation. And I really can do anything I want to one side as long as I do it to the other. I could square both sides. I could take the square root of both sides. I could take the logarithm of both sides. I could divide each side by 172. In other words, I can truly do whatever I want to one side as long as I do it to the other. Well, the key here is I want to get that to just z. So the trick is to figure out what I need to do to the right side of the equation so that I'm left with just z. And it turns out that it's add 8.
Yeah. So you add 8 to negative 3 and add 8 to 0.
Well,
8 to z.
I'm really adding 8 to negative 8, producing 0. And the left side is what? What's minus 3 plus 8?
Minus 3 plus 8 would be 5.
Okay. What am I going to do here?
Oh, on 7?
Uh-huh.
Okay, so you add negative 6 to 6 on the right side, and so that would mean you also add negative to 14, to negative 14.
Okay.
And then you get negative 20 equals k.
All right. Have you done some of these already, or do we need to look at every one of them?
No.
You seem like you know them pretty good. So usually when that's the case, tell me what I'm going to do on 9 to solve for it.
On 9, you would... Oh, what's that? 1 second, something just popped up. Let me close out of it. Okay, so on 9, you would add 7.6 to negative 7.6.
Well, state it like this, David. You would add 7.6 to both sides of the equation.
Okay.
And what that leaves on the left side of the equation is just c. And what it's going to leave on the right side of the equation is minus 4 plus a 7.6, which is 3.6.
Okay.
Okay? So number 10, what are you going to do to both sides of the equation?
Well, I think that's a plus.
It is. Mm-hmm.
Okay, so, you would subtract 5.3 to both sides of the equation.
Okay, good. And number 11, what are you going to do?
On number 11, I think that's addition again. You would subtract 2/3 to both sides of the equation.
So what is 1/2 minus 2/3?
1/2
So that's equal to Q.
Yeah.
Mm-hmm.
So 2/3 is equivalent to 4/6. 1/2 is equivalent to 3/6. So that would amount to negative 1/6.
Good. And that's equal to Q. Okay, what are you going to do to 12?
You will add 3 and 1/6 to both sides of the equation.
There you go.
Okay, and
13?
should I explain how? Oh,
No.
okay. So,
No, we won't get totally bogged down in arithmetic here. As long as you know what you have to do. So 13,
Yeah.
what are you going to do?
you would add 9 to both sides.
14?
I thought you said
No, yeah, that's good enough for 13.
Oh,
That's correct.
okay. I see.
Okay, so 14, what are we going to do?
Okay, so for 14, we're going to add 3.4 to both sides.
How about 15?
Subtract 4 and 58/100ths.
From both sides of the equation, okay.
Yeah.
16?
You would add 5.2 to both sides.
Good. 17?
Subtract 5/9 to both sides.
About 18?
Would add 4/5 to both sides.
And 19?
Subtract 3 3/8 from both sides.
And 20?
Subtract 4 2/5.
Very good. And I'm going to assume you can do all of that arithmetic. I'm pretty sure you can.
Yeah, I need a pen and paper, but yeah. I can.
Right. But that's not what you need help on.
Yeah.
Okay. I'm not sure you needed help on the other, but it seems to me like you understand this stuff pretty good. What's the error here?
So the error, let me look at it really quick. So x plus 8. Well, we don't know what x is, so we can't.
What should we have done to the both sides of the equation?
You should have subtracted 6.
8.
That's what I meant to say.
Right. And they added 8 instead of subtracting it.
Yeah.
In other words, the way they did it, this line right here should say x plus 16, because when you take x plus 8 and you add 8 to it, you get x plus 16.
Yeah.
So that didn't really equal x. So they needed to subtract 8 from both sides, and then we would have x equals 2.
Okay.
Okay? All right,
Yeah.
write the verbal sentence as an equation and then solve. What does it mean if I say 4 less than a number n is negative 15?
Negative 15 equals 4 minus, no, n minus 4.
There you go. And I probably would have written this from left to right. I would have done this. Now, it's the same thing. There's no difference between these two statements. It's just that typically you can't fully write left to right because they always do this little trick where whenever you're supposed to subtract a number from a variable, they always start out by giving you the number. In other words, they're trying to confuse you a little bit there. They could have said a number n minus 4 is equal to minus 15, but they didn't say that. And that's the way it's going to be for the next 4 or 5 years in math for you. So you want to get used to that. If a sentence starts out 4 less than a number, know that you always have to take the variable and subtract 4 from it. Okay, so what's the solution?
For 23?
Okay, we're solving n minus 4 equals minus 15, right? So what do we have to do?
So you have to add 4 to both sides of the equation.
What is negative 15 plus 4 equal to?
Yeah, it would make it negative 11.
There you go. Now notice I don't really bother to write over here plus 4 because I know what I'm doing is going to reduce it to n.
Yeah.
So to me it's kind of superfluous, although I know that when they're just teaching it to you, they they like you to write this plus 4 on both sides in this manner here. But after you do it for a while, you get so you don't almost have to do that. But we'll do it. Okay, the sum of a number y and minus 3 is minus 8.
Okay, so it would be y plus negative 3 equals negative 8. And it could also technically be y minus 3 plus negative 8. I mean, plus negative 8? Yeah.
Okay?
So you would add 3 to both sides of the equation. And then you get y and negative 5. Y equals negative 5.
There you go. How about 25?
For 25, p minus 6 equals negative 14. So in that case, you would add 6 to both sides of the equation, getting rid of negative 6 and making negative 14 negative 8.
Good.
Then
Not sure. Let's just talk about 25 for a moment. Technically, I could have written 6 minus p is equal to minus 14, because when they say the difference between a number p and 6, they're not really saying whether that's p minus 6 or 6 minus p. I'm sure that at this level they want you to write p minus 6. So the way we did it is correct. But notice that when I say the difference between two numbers x and y, that can be x minus y or it can be y minus x. So unless I specifically say p minus 6, you don't really know. I don't really want to throw that monkey wrench in there, but it's not helpful to you at this point. Okay, how about 26?
Okay, the temperature of dry ice is negative 109.3 degrees Fahrenheit. This is 184.9 degrees Fahrenheit less than the outside temperature. What is the outside temperature?
Okay, so first of all, we need an equation.
Okay, so the temperature of dry ice, so that means the answer at the current moment would be x. And then that would be...
Let's write this equation exactly as we see it.
Okay, so...
Minus 109.3. See this is right there? I'm sorry, this is right here that I'm pointing at? That means equals. Now I realize there's an is there also, but what they're saying is that this temperature, minus 109.3, is 184.9 degrees less than the outside temperature. So if I let x be outside temperature, what's my equation going to be?
So our equation would be 189 minus x?
X minus 184.9.
Oh,
In other words, again, they give you the part that's being subtracted first in the sentence. They say this is 184.9 degrees less than x, and that's what that means. It means x minus 184.9. Doesn't mean 184.9 minus x.
okay.
So, and notice that's the same. In other words, the 184.9 was being subtracted. Up here on 22, the 4 was being subtracted from in. So just because the 4 is listed first in the sentence doesn't mean that it gets listed first in the equation.
Okay.
Okay, how do I solve this for x?
So for 22,
Actually, for 26?
sorry, your mouse was over 22, I think.
No, I know.
Okay.
I was just, because that's a similar word problem to 26, it has the same basic feature where you're supposed to subtract this number from x, and yet the sentence lists that first and then says less than.
Okay, so you would add 184.9 to both sides of the equation.
Okay, so what does
And
x
then
equal?
x equals, well, technically you would switch them around, so you'd get,
Yep, I did in my head.
you would get, yeah, yours is right, 75.6.
Okay, so now let's see if that makes sense, because one thing you should always do is when you've solved a problem like this, test it and see if this makes sense. Is the temperature of dry ice 184 degrees less than 75.6?
So
Let's draw a number scale, because this can be helpful. Here's a number scale. Here's the current temperature, 75.6. And we got to go this direction by 184 degrees, right?
yeah.
Because it's less. It's 184.9 degrees less than this number. So we said that means this should be minus 109.3. Now, does this all make sense?
Mm-hmm.
Yeah.
And
75 degrees is 184 degrees more than minus 109.
yeah.
Because it's the sum of this distance plus this distance. So we worded it correctly. Had we made a mistake, let's make a mistake here and see what happens. Had we made a mistake and said 184.9 minus x, which is the mistake that a lot of people will make, now notice that I need to add x to both sides to turn it into a positive, and then I need to add 109.3 to both sides to get rid of it. So this would become x equals, and I would add 109.3 to this number to get 294.2. So had I made a mistake, I would have come up with an outside temperature of 294 degrees. Now, that would not agree with this statement.
Yeah, you'd have to be on another planet.
Well, that's one sign that you would be wrong, is that the temperature would be beyond what our outside temperatures are. But another reason would be, well, this makes the outside temperature 294 plus 109, about 400 degrees bigger than dry ice. So something's wrong. I made a mistake when I come up with an answer like that. And the mistake would be the obvious one that everybody makes with this, which is to put this first minus x instead of x minus that. So that's the thing you have to be careful with on word problems. Okay, 27.
Profit. A company makes a profit of $1.38 million. This is $2.54 million more than last year. What was the profit last year?
Okay. Let's turn this word problem into an equation. The best thing for an equation is always to start out by defining your variable and listing what it is. So I'm going to say x is the profit last year. So now Give me an equation.
1.38 plus x equals 2.54.
Well, let's write this exactly as we read it.
Okay. So
In other words,
1.38
that's
equals.
equals. In other words, this is, and this is becomes an equal sign. So I can immediately, by the time I get to that is, I can write that much of the equation. 1.38 million equals. Well, if it's 2.54 million more than last year, what's the right side of this equation look like?
That would be 2.54 plus x.
There you go.
Okay.
And now what is x going to be? Or how are you going to solve for x?
You would subtract 2.5 million to both sides.
And that becomes... So last year the company didn't make a profit. They actually had a loss of 1.16 million.
That's not good.
No, it isn't. You don't want a company that has a loss of 1.16 million.
Yeah.
But that's what happens with companies. They really do. They operate in those realms. Sometimes they can lose $1 million one year and make $2 million the next. Sometimes some companies like Google, when Google first started, they lost money every year for the first 6 years.
Wow.
But now they make enough money in any given year to totally make up for everything they lost in the whole 6 years. So,
Yeah.
so I guess the moral is that companies don't always make a profit. Sometimes it's a loss, and you have to consider that when solving these. Okay, peer. The difference between... Go ahead.
You get okay. The difference between the length of a paddle boat and a pier is negative 7 3/4 feet. The pier is 18.5 feet long. How long is the paddle boat? So,
I hate this question, but I'll do it anyway. First of all, the difference between these two. In real life, you never say the difference between two things is a negative anything. If I said the difference between the length of my desk and the length of my car is 10 feet, then one of them is 10 feet more than the other. But I would never say the difference between the length of my desk and the length of my car is negative 10 feet. I guess what they're trying to get you to do here is the paddle boat minus the pier is minus 7 3/4 feet.
I guess.
I think that's what they're going for. In other words, they want you to list it in the same way they list it in the sentence. They list the paddle boat first and the pier second. So the algebraic representation of that is paddle boat minus pier. Although that's not really true. It's like this 25 where it says the difference between a number p and 6. Technically, I can write that p minus 6 or 6 minus p. They kind of are assuming that you take the first one minus the second one. So that's okay with me. I don't mind that convention. So I can write that paddle boat minus pier is equal to minus 7 3/4. What's the paddle boat or what's the pier?
Okay, it's 18.5 feet.
So now all I have to do is solve this.
So you add 18.5 to both sides, which would get you to Okay, yeah.
I think.
Wait, no, 1/4. 1/4.
1/4? Okay, that's what happens when you do math in your head. No, 3/4 is right.
Really?
Yeah, if I add this to this, I should get 18.5. And I do. Do it on your, do you have a calculator in front of you?
Yeah.
Just do 18.5 minus 7 3/4.
18.5 minus 7.75.
You should get 10.7.
Oh. Well, I guess that's what I get for doing math in my head.
That's okay. I love to see people do math in their head. I do, because I think you learn math better when you practice it like that. I hate it when people depend on a calculator for everything. I had a student who was a senior in high school, and I was tutoring her, and I asked her, there was a question that, what is this number times 10? And she had to use your calculator to do it.
What?
No kidding.
What?
That's somebody who has done every single calculation in their life by calculator, such that they don't even realize that when you multiply a number by 10, you just add a 0 to it.
Well, yeah.
But that's the dangers of over-calculator use. Now, going back to this peer problem, you understand my problem with their wording? I don't really know which is bigger. Is the paddle boat bigger or is the pier bigger? Well, typically a paddle boat would be smaller than a pier. So it's reasonable that the paddle boat would come out to be 10 3/4 feet and the pier is 18.5 feet. So that makes sense. But based strictly on their wording, we really don't know if the paddle boat's bigger or smaller than the pier. So theoretically, the paddle boat could be 25 or 26 feet long, and it would still be a difference of 7 3/4 feet from the pier. But I probably shouldn't be saying anything because they probably want you to interpret these word problems in exactly the way they're saying them. In other words, when they say the difference between the paddle boat and the pier, they mean PB minus P. They don't mean the other way around. Just like this difference between a number P and 6 was P minus 6. But that's not necessarily going to hold true next year or the year after for you. When you get into high school, that will not be a true statement.
Okay.
Usually in math, when you say the difference between two things, it means you can subtract them in either order. And the difference always comes out positive. So they're doing it a little different here.
Okay.
Okay, so what was we want to go back to,
There's another page.
oh, there is another page here.
Yeah. Yeah.
Ah, yes there is. Okay. You want to continue on to this other page? Or you had one other section you wanted to look at too? Your choice.
I do whatever you think is best.
Okay, well I haven't looked at the other section. Let's go ahead and finish this page. It looks like we get little geometry problems here, which can't be bad. So if the perimeter is 12, what equation can I write?
Well,
Can I interrupt you just one second? This is my next appointment. They might be canceling, so. Hello? Hey, Mark. Okay. I'll show up. I'll show up at about 7. How's that work? Okay. See you then. Bye-bye. Okay, sorry for that. I don't usually answer my phone when I'm in a session unless it's the next appointment that I have. Okay, so perimeter equals 12 centimeters. So what can I write as an equation?
You could write 5 centimeters plus 3 plus x equals 12.
Good. Solve that.
Yeah, it equals 4.
Okay.
And
So what you did was you subtracted, you first added those together to get 8, and then you subtracted 8 from both sides.
yeah.
Okay, how about,
And then I also know that whenever it goes like 3 or 5 or 3 or 4 or 5 or 4 or something like that, it'll always be 3, 4, 5.
actually not. Only right triangles are 3, 4, 5. And nowhere are we told that that's a right angle. If that's a right angle, then you're absolutely right. That has to be 4. And in this case, that is 4, so this is a 3, 4, 5 triangle, and that tells us that has to be a right angle. If you have a 3, 4, 5 triangle, it has to have a right angle in it. Okay? What's the equation we're going to write here? Just read it for me. I won't write it.
Okay, the perimeter is, okay, so it'd be in parentheses 8.3 times 2 plus 3.8 plus x equals equals 24.2.
Okay. And you know to distribute that and then move both numbers. In other words, this is now 2 or 3 steps that you have to do from this point forward. So the way I would do this is I would multiply these together. So I would get 16.6 plus 3.8 plus x equals 24.2. And then I would subtract in one step. I could subtract 16.6 and subtract 3.8. So I might not have to add these two together first. That equals 20.04, so our answer is 3.8. So what does that make that figure if that's 3.8? What kind of figure is that called?
A parallelogram.
Very good. Have you had much geometry or just probably not a lot, huh?
A little bit, yeah.
Yeah.
Like we figured out 3D shapes. We know how to find the surface area and the volume and stuff.
Uh-huh. Okay, 31, I suspect you know how to do it. Let's not spend our time on it.
Okay.
Unless you don't. I mean, any of these that when I make that statement, if you know how to do it, let's go on. But if you don't, we'll look at it.
Well, I was wondering, I never actually heard of that way that you subtract in one step.
Well,
Like
okay.
I've always been taught where you
add the two together.
Well, not technically that, but you find the one of both of them, and then you subtract the solution you just got, and do it again.
If I gave you this equation, x minus 3 minus 5 equals 10, notice that I don't have to do this first. I can just take each piece of this. I can look at this and say, I want to move that to the right side. Well, I do that by changing its sign. And I add 3. I can do the same thing to this. I want to move that to the other side. Well, I'm going to change its sign. So now x equals 18. Notice that that was maybe easier. I don't know. That's just the way I do it. The other way would be to combine these first. So you get x minus 8 equals 10, and then add 8 to both sides. But remember the first rule of algebra. You can do anything you want to one side of the equation as long as you do it to the other. So in one step I added 3, and in another step I added 5, So there's nothing that says I have to combine those numbers first.
Well, the really hard thing is so you added 3 and 5 at the same time, but I never heard of subtracting 3 and 5 or something like that.
Well, if that was our equation, we can tell x must be 2, right? Okay. Well, how would I get it? I'm going to take this plus 3, move it over to the other side. I'm going to take the plus 5, move it over to the other side. And I'm going to have 10 minus 8, which equals 2.
Cool.
Yeah,
Okay.
you don't have to combine everything first, because sometimes they won't be numbers. Sometimes, what if I had something like this? Have you dealt with any multivariable stuff yet?
A little bit.
Well, if I had this equation here, and I said solve for x, well, I can't combine those really, because one's a letter and one's a number. But what I can do is I can add y to both sides, and I can subtract 3 from both sides. So that gets rid of that and leaves me with x equals 10 plus y minus 3, or 7 plus y.
Okay.
Okay? So, and that's pretty much, have you had problems of the following nature, where if I said x divided by 3 equals 9, how to solve that?
Well, it'd have to be x divided by 3 equals 9. And so the only number divided by 3 that it would equal 9 is 27 over 3.
Right, but there's an easier logic than using that. I mean, in simple problems, that'll get you to the answer. But if I make this problem more complicated, you're not going to be able to solve it like that. But what can I do to the left side of the equation that I can do to the right side of the equation that changes the left side of the equation to just x?
You multiply x by 3 and multiply 9 by 3?
Exactly. You don't multiply x by 3, you multiply the left side of the equation by 3.
Okay.
Okay, that causes those to cancel, and you're left with x equals 27. So what I was trying to get at is that when you have an equation where you're dividing by something instead of subtracting or adding, then the way to solve it is you don't subtract or add from each side, you multiply by each side. Or what if I said this?
Well, you would just divide each side by 2.
By 4. Because notice that when I divide the left side by 4, those cancel, and I'm left with x, which is what I want. So the whole point of algebraic solutions is to handle problems where you wouldn't be able to figure it out in your head. In other words, if I said this, you're not going to be able to do that in your head. Right?
Yeah.
However, I can multiply both sides by 7. That cancels that denominator. Now I got 3x minus 1 equals 343. And now I'm going to add 1 to both sides. So I got 3x equals 344. And now I'm going to divide both sides by 3 so that I got x equals 344 divided by 3. So that's how you solve a more complicated algebraic equation.
Oh,
In
cool.
other words, equations that involve division and multiplication as well as addition and subtraction. And they get complicated enough that if you didn't have those rules, in other words, if I didn't know I could do whatever I want to the left side as long as I can do it to the right, I would have a hard time figuring out what this value of x should be. In other words, it wouldn't be as simple as what you did when I said x over 3 equals 9. Well, you figured out, well, x has got to be 27. That's the only thing that works. And you could do that in your head, but this one would be harder. And in general, algebraic equations are going to be harder than you can do in your head. So you're going to have to learn these techniques of doing the same thing to the one side of the equation as the other. And believe me, that is the most important principle you can learn in algebra, is when you solve equations, you can do whatever you want to one side as long as you do it to the other. I said the square root of x equals 4. You know what square root means of x?
Yeah, so that would mean x equals 16.
Right, but how do I get it? I get it by squaring both sides. In other words, I don't multiply or add or divide or anything, but I'm going to square both sides. I'm going to square this side, and I'm going to square that side. Well, when I take square root of x squared, that's square root of x times square root of x, which is equal to x. So now x is equal to 16. So there was a principle where I didn't add, subtract, multiply, or divide, but I squared both sides. Well, it applies in all math all the way up to calculus. When you get to calculus, you can take the derivative of both sides. You can integrate both sides. You can take the logarithm of both sides. As long as you do the same thing to each side, you can do anything you want. All right. Let's look at our Statue of Liberty problem here.
The total height of the Statue of Liberty and its pedestal is 153 feet more than the height of the statue. What is the height of the statue?
Okay, there's the pedestal, there's the statue. So let's write it as an equation.
So it says
What's our variable?
our variable is the height of the statue.
And you can almost always get that by looking at the very last sentence. Whatever that last sentence is asking for, that's going to be our variable. We don't have to let it be x, let's let it be h. So now let's go through this sentence and write an equation based on this. The height of the Statue of Liberty, h, and its pedestal is what?
The height of the statue. Right, no.
153 feet more than the height of the statue. So what is that? 153 plus h.
Really?
No, I'm missing something here. The total height of
Wouldn't it
the
be
Statue of Liberty.
153 minus h?
Yeah. Hold on.
Because
Hold on. The total height of the Statue of Liberty and its pedestal. So if h is the height of the statue, the height is 153 feet more than the height of the statue.
And we know that in total it's 305 feet. So,
I think they have a, oh, I wasn't looking at that.
yeah.
Okay, so this distance between here, no wonder I was missing something. So this distance from there to there is 305.
Yep.
Okay, so the height of the statue and the pedestal, I can substitute 305 for that. And that's equal to 153 feet more than the height of the statue.
And so,
Plus because it's more. So what's the height of the statue?
so what? 305 minus 153
It's 202.
is...
Oops, excuse me, it's 152. So 152 equals h. Does that make sense?
Uh-huh.
Yeah, because if this is 152 and this is 153, then they total 305. So I'm going to suggest you always do the ballpark check when you're done.
Okay.
Just because it's easy to get these mixed up. In other words, you almost did 153 minus h, and that would have given you a negative number for h. So when you get a final answer and you look at the problem, make sure your final answer makes sense.
Okay.
And if the height of the statue was 152, then the total height of the statue and pedestal would be 153 feet more than 152. And that's correct.
Okay.
Okay. Okay. We started a little late. We can end now if you've got something else going, or we can do a few more.
Whatever you think is best.
If you've got time, let's keep going. Let's try to do an hour every time we do a session.
Okay, so...
It's like anything else. Do you play any sports, David?
yeah.
What do you play?
I play tennis, and in the winter I ski.
Okay, so you're a tennis player. Do you have a tennis coach?
I take a public class.
Okay.
And
So you have a teacher that teaches a group of kids?
yeah.
Okay. Well, if you get really good at tennis, my guess is that your mom will sign you up for individual lessons. And the better you get at tennis, the more you're going to need a coach. That's just the way it works. Well, I kind of think the same thing is true with math. Math is a skill that you will really benefit by exceeding at that skill big time. So I think most of my students tend to be smarter than not. It's not a question of needing tutoring because you don't understand the subject material. It's a question of getting tutoring to get yourself brilliant at math. In the same way that if I was giving you tennis lessons, you would get better at tennis. So that's the way I think you should try to look at tutoring. It's not something that you need just when you're having trouble or when you don't understand something. It's something that's going to help you in all of your math. It's just going to make you better at math.
Yeah.
Whether you need a lesson, in other words, even if you felt like maybe you didn't need a session tonight, it was worth practice. It'd be like going out and practicing tennis for an hour when you didn't really feel like you needed to. But practice always makes better. Always makes, not perfect. I like to say practice makes less imperfect, because it doesn't usually make perfect. Nobody's perfect.
I don't think it can make perfect because
No, there's no such thing as perfect.
because no matter what, you
Right.
do something and there's always a way to improve it.
That's exactly right. Nobody plays golf in 18 shots. There's 18 holes of golf, but nobody makes a hole in one on all 18 holes. So, let's look at another geometry problem. Let's look at 35.
So the sum of the measures of the angles of a triangle equals 180 degrees. What is the measure of the missing angle? So you would add 30 well, technically it would be 30.3 plus 40.8 plus m equals 180.
Right.
And then the way I would do it is that you subtract 30.3 and 40.8 from both sides.
Yep.
And it amounts to...
Let me give you a good way to do this in your head. 30 and 40 is 70. 0.3 and 0.8 is 1.1. So if I add 1.1 to 70, that's really 71.1 that I'm now subtracting from 180. Well, the difference between 180 and 71 is 109, but I got this little piece extra, so it must be 1/10 less than 109. So it has to be 108.9. That's the way I do math. And the difference is I usually go left to right. They teach you to do math going right to left because of the rules that we use. In other words, they would want you to add a 0 to there and then start on the right and go down and then that one and that one and that one. But I find that in the real world, the more significant numbers are the ones, the bigger ones, the ones to the left of the decimal point. So if I subtract 180 minus 71, I get 109 in my head. That's real close to the final answer. That's the most important number to have in real life, is something that's really close if you're wrong. And then I got to take away 1/10 from that because I still have this 1/10 over there. And taking away 1/10 from that makes it 108.9. So everybody has their little tricks for doing arithmetic. I have mine. They don't always agree with the way it's taught in the classroom, but it's worth knowing different techniques.
Your first jump is 50 and 1/6 feet higher than your second
I
jump.
made that mistake.
Your first jump reaches negative 200 2/5 feet.
You know what I think
What
it
is the
was?
height of your second jump?
I think it was
You
when
think you what?
I think that audio came on when I got the slide bar all the way to the bottom.
Let's see on mine.
Although
Not
how
happened to me.
did it know we were on the bungee jumping question? I didn't put my cursor over that at all.
I don't know. Maybe you accidentally clicked it when you were reaching.
I might have. Well, yeah, it's not what I thought. It doesn't go off when I hit the bottom because that one wouldn't have gone off. I must have, I don't know. That's kind of curious. It seems to go off randomly, doesn't it?
Mm-hmm.
All right. Why don't we end there? We've gone an hour. So
Okay, cool.
it's a good spot to end. Well, good. You don't have any problems on this, and you should do good on your next test on this material.
Cool.
Yeah. All right, David. I will talk to you next Wednesday.
Okay.
All right?
Thank you.
All right. Good night.